Next, I want to talk a little bit about geologic time. Just give a very, very brief overview of geologic time and some of the major events that have happened in Earth's history. Remember before, we learned that the present is the key to the past. And we're going to be learning a lot about reading the rock record in this course. So just having a quick overview to see what some of those big events are is going to be useful to us. Here, we've got the life of Earth written out as best as we understand it today in terms of mega annums, millions of years. So you want to remember MA means million years. And that's a 1 with 6 zeros. Remember that. GA is billion years, giga annum. And that's 9 zeros. Huge, almost incomprehensible amounts of time, going all the way back from today, all the way into the past, right? We said about 4.56 billion years ago, or 4,560 million years ago, I mean the same thing, Earth and the planets formed. Just 50 million years later, we think approximately the moon formed. And then it took some time for Earth's continents to separate from the ocean basins. And so about 4 billion years ago, we think the oldest continental rocks formed. We see our first evidence of water erosion, making us think that now we've got a hydrologic cycle. We have oceans at this point. It was maybe 3.8 billion years ago. 3.5, we see a record of a magnetic field, which means that the Earth's geodynamo is working. We see fossils of primitive bacteria, which means that we definitely have life at this point. It might have existed earlier, but we just haven't found evidence, great evidence of it yet. And some, this is a thing that's argued back and forth by scientists a lot, reading different things in the rock record. But we didn't have animals yet. This is at most primitive bacteria. So the evidence gets hard to interpret as you go further and further into the past. It took until about 2.7 billion years ago for oxygen to start to accumulate in the atmosphere. And by 2.5 billion years ago, roughly the major phase of continent formation completed, which means that for the most part, the rocks that make up the continents, or at least their general area in the basement way down underneath even the rocks that we see on Earth's surface, most of that is formed by about 2.5 billion years. We'll talk more about that in detail. Then it takes about 2 billion years for most animals on Earth to start to evolve. So really animals, these multicellular collections of organisms that can move around, collections of cells that can move around, it took until about 500 million years ago, a little more, maybe 600 million, for those to start to exist. And we know this really well because we start to see really good fossils around this point in time. This evolutionary Big Bang at the start of the Cambrian period is when lots of different organisms evolved to have hard parts, shells, teeth, bones. Before that, we were just globby bags, basically, jellyfish, right? Once we hit this part and we start to develop hard parts, then there are going to be a lot more fossils for us to be able to interpret. Now, most of those living things were probably still in the ocean. At about 420 million years ago, we get the earliest land animals. And just shortly before that is when we see the earliest land plants. Then it takes until about 125 million years ago before flowers develop. So land plants were probably a lot more like moss or lichen or some pine trees before about 125 million years ago. Then it takes until only 5 million years ago, the first hominids, the first upright walking, vaguely humanoid shaped living things developed about 5 million years ago. So it's really very recent when you look at the whole span of of Earth's history. That's what, 0.1% of Earth's history we've had hominids on it. And our species didn't appear until 0.2 million years ago, that is 200,000 years. So humanity has only been around for a very short period of time, and in that time we've affected Earth's surface a whole heck of a lot. I want to note here that the way that we know this information is related to geology very, very closely, because it's the rocks that we read for their record of the rise of life, the development of oceans, continents, atmosphere. That's where we get the evidence. That's the stuff that's left behind for us to interpret. There are no books telling us about it. We can't stick a telescope out in space and look back into our own past. So really, it's only the rock record that we get to read. It's only from geology that we have an understanding of Earth's history. So you see some of these events listed on here if you want to read them in a little easier to read font, but we have gone over most of those at this point. I will note that a major feature in Earth's history are these mass extinction events, which cause rapid and major changes in the biota that existed at Earth's surface as a result, certainly back then, of natural processes. Things like impacts of huge meteors or eruption of huge amounts of igneous rock at Earth's surface that affected the atmosphere and probably made the oceans nearly totally anoxic or without oxygen, would have killed off a lot of life. So these features have occurred over the past hundreds of millions of years, and they probably occurred further back in time too. We just don't have as great evidence of them.